Good morning, this is Dr. Gondikonda Reddy. I would like to explain about this mechanics of solids lab, where we are calling it as strength of materials in civil engineering department. In mechanical engineering department, we are calling it as mechanics of solids. So this is the entrance of mechanics of solids lab in our college, and see the entrance for this. This is the entrance. This is the way how we have to come. And see, this is, we are about to enter into this mechanics of solids lab. Just see here how it is there. Just I would like to explain one after the other how the experiments are there here. The first one I would like to show, just see, it is a spring testing mission. So for a given spring of tensile spring, we can find modulus of rigidity of the spring, because that is one of the property of this spring, modulus of rigidity G. So that value we can find. It may be around 0.6 to 0.8 into 10 to the power of 5 Newton per mm square. That we can test it. See where we can apply the loads here. We can apply the loads from here, from this point. From this point we can from this point to this point we can fix the spring, and in the dial gauge we can see the load, and we can find the deflection on the scale likewise. So by using the formula, by getting the values, we can find modulus of rigidity of the given spring. Likewise, we are having torsion testing mission. Just see the torsion testing mission, how it is there. We are applying the torque equation here. It is the torque we are getting here. It is the motor. As the motor rotates, it twists this shaft. This shaft is going to twist. So this angle and all we can find here. We can have it. See here, this angle, we are having the angle here, you can find the angles here, just see in the scale. So at how much angle it is rotated, like that we can find, and the length of the shaft we know it. And from all the values, it is the starting point of this torsion testing mission. And we know T by J is equivalent to G theta by L is equivalent to Q by R. That using that formula, we can find once again modulus of rigidity of the given spring. Now we are having one more equipment called Charpy and Izod test. See here the Charpy and Izod test. It is the pendulum when we are having 141 degrees with this base from this entire angle. If you are having this angle 141, so we can say it is a Charpy test. So it is a pendulum. Just see it falls at the ground. So it hits the specimen. So it breaks. Just see. So here we can find the impact energy. Let us say we did not have any specimen over there. What happens? It is showing zero energy absorbed by the specimen. So the difference between this Izod and Charpy test is, in Izod test we are using the 90 degrees. It is going to be horizontal, the entire pendulum. And here we are going to have, the Charpy test we are going to have 141 degrees. So in Izod test it is only 90 degrees. Likewise, we can find impact energy of the absorbed by the specimen, we can get it. Likewise, we are also having Brinell hardness test. You just see the details of this Brinell hardness test. We are having maximum load 3000 kgf, and ball indenter diameter is 10 mm. This is the equipment we can have. Here we can find out the hardness of the some kind of material like brittle materials, ductile materials like steel likewise. So what is the hardness of this specimen, BHN number? Just see, we can provide the specimen here, then we are applying the load. Then we can find on the specimen there is impression of this indenter. Here we are having the ball indenter. I am unable to show it here. There is a ball indenter with my finger. This presses the specimen, so we can see diameter of the impression. By the diameter of the impression, we can find out with the formula the value of BHN number. Then we are having one more hardness test, Rockwell hardness tester. For hard material we are using it. You just see, we are having ABC scales. The A scale we are having 60 kg of load, and B scale 100 kg of load, C scale 150 kg of load, and we are having different kind of indenters. Just see it, this is, we are keeping the material here like tool steel, and we are pressing it directly by applying it. in a proper procedure, we can find out the value of RHN number, Rockwell hardness number. Then we are having one more test, simply supported beam. Here, you just see the simply supported beam. So here we are applying the loads and we are providing the dial gauge at this with this stand. So when we are applying the loads, we can find out the deflection of the beam. Likewise, for different loads, we can have different deflections. So we are going to have maximum deflection at the center of the beam. So we can find out different deflections for different loads. Based upon that, it is practically we are getting. We can also compare with theoretically from deflection of beam equations. So this is one of the tests we are having in our MOS lab as well as strength of materials lab. Now we are having one more test is cantilever beam. It is similar to simply supported beam only, but it is a cantilever beam. One hand is fixed, this hand is fixed, we just observe it, this hand is free. Then we are applying the load, at end also we can provide, and only we have to find the deflections. So this is the stand to fix the dial gauge. Then this board will be there to use in this lab for explanation for the teacher, to the students, those who are coming to the lab. Then we are having one more compression test. This compression test, when we are providing this, on this base we are providing different material, and as we are fixing the stand, then with motor and operated, both way we can use it. So then we can see different readings here. As it breaks, the specimen breaks. So it is a high value up to 200 tons, we can see it. If it is a medium value up to 100 tons, we can see it. If it is a minimum value like 50 tons, we can see it. Just it is like this. I just see the machine, and the machine is there like this. And these are some kind of material they kept for here to know the compressive strength of the material. Like we are having clay bricks, like we can have cement bricks. Any material we can use it. Even some kind of steel material we can use it. And later we are having one more equipment called tensile testing machine. So on tensile testing machine, generally machine is used for some specified specimens like 8 mm specimens, 8 mm square bars, just so that they can fix over here. Other things we are unable to fix this. Let us say we are having 10 mm, 12 mm, we can't fix it here. It is standard specimens, we can use it to find out the tensile strength of the material. We can find, we can draw a stress strain curve for this mild steel bar. So this is the load we can see, and we can have the scale here. Likewise, we can use it. Then it is also operated with hand instead of motor. Both way we can use it. Likewise, one of the important tests we can use it is UTM, Universal Testing Machine. Here we are having 40 ton UTM, we can see it. Just see the UTM, the UTM entire system, and it is operated with hydraulic operation. Just see it. So here we can find out the load in terms of kilonewtons, newtons. Likewise, here we can have the deflection. Manually we can get it, and or otherwise we can also get through directly. Its value is plotted and is in the system. We can see stress strain graph directly. So we can get the graph and print out to this printer also. Likewise, we are having some material which is used for different kind of equipment to test. See, these are the cement bricks to find out the compressive strength of the material we are using. And this is one of the almirah we are using to keeping some material in the lab which is useful for lab purpose. Then we are having different materials, specimen materials. I am keeping here. We are keeping here. Sorry. There, whatever the specimen length we want, we are cutting it and we are using it for different experiments. These are all electrical control systems. They are there here. Further, we are having different kind of material here. Just have it. Then I will show you a few more equipment here. Just see here. This is one of the color printer we are used earlier for this lab purpose when we are having metallurgy lab. Then we are also having, just see it, this is a shear punch test equipment where we are using the material here and we are pressing it with UTM. So at what value it is cutting the material, that we are knowing it. It is shear punch test we are having in strength of materials lab for civil engineers, civil engineering students. Likewise, we are also having continuous beam. This is the continuous beam. We can use it as, we can keep it middle. So we can have more, when we are having more than two supports we are having, it is saying it is a continuous beam. Here we are having more, actually we are supposed to keep at the middle. So when we are keeping like that, it is a continuous beam, and one side we are fixing the load, providing the load, the other side we can take the deflection. That is one value, and vice versa we have to do it. That is, this side we have to provide the load, the other side we have to take the deflection likewise. Both we are going to have same value. This is continuous beam, and one more is there for civil engineering student, strain gauge, that is also available in the lab. I am unable to show it at right moment, at this moment. Strain gauge is also there. Altogether, the civil engineering students, they are having 13 experiments. Mechanical students, they are having only 10 experiments. Beside of it, the students, they are also having exposure to some kind of equipment. What I am showing here, just see. It is a project got by one of our colleagues. Here, just see. We got it in AICT project. It is a stress analysis RPS project. AICT's RPS project, stress analysis of composites. So some light waves, we can get it like this, this mirror and all, we can see it, and we can apply the loads and we can get it like that. And these racks and all used for keeping all this equipment which are relevant to this equipment, and these are further material like aluminum and all, we are using it. This particular material is a composite material. We can use it as a beams and we can find out the reflections like that. Then this is also almaras, we can use it. We are keeping some material of labs like dial gauges and all in this room. Then I am showing you one of the equipment, impact testing mission, which we got as project for one of our colleagues. See it, it is impact testing, it is fatigue testing mission, and this is the specimen, and as it rotates at particular cycles with some load, it is going to fail. So at how many cycles it is going to fail, that we can calculate, and it will give the reading directly in this gauge. That value we can see it. Thank you.